My name is Christian Georgi, and I'm a product owner for the SAP Cloud Application Programming Model.
And my name is Karin Chuto-Jomo, Product Manager for the ABAP platform. In this unit, I will give you a compact overview of the ABAP RESTful programming model.
We are going to focus on how you can develop OData services, which serve as backend for your SAP Fiori application. Let me introduce you to this topic. You are going to learn about the two major REST-based enterprise programming models of SAP. These are the SAP Cloud Application Programming Model, or CAP for short, with which you can develop OData services in Java or Node.js JavaScript. Secondly, you will see the ABAP RESTful Application Programming Model, or RAP in short, which allows you to develop OData services with the well-known ABAP programming language and infrastructure. This slide shows the structure of an SAP Fiori application at a high level. First and foremost, there is Core Data Services, or CDS, which acts as the ubiquitous modeling language. Using CDS, you can declare how your domain model looks like and how it maps to the service model. One layer up is where we find the enterprise programming models. This is the place for the runtime components that do the heavy lifting of an application. They implement things like generic support for CRUD requests, including extensibility, database persistency with SAP HANA, support for SAP Fiori draft documents, or convenient connectivity to other services of SAP Cloud Platform. In addition, they manage the custom code that application developers write to enhance the backend logic. Both the SAP Cloud Application Programming Model and the ABAP RESTful Programming Model integrate quite symmetrically in this layer. This means the client part, like SAP Fiori, doesn't need to care if the application's backend was developed with one model or the other. In the next layer upwards, there is protocols with OData and REST as prominent examples. These establish HTTP APIs that the clients can rely on and that the bottom layers need to implement. And on the top, you see the client software. This could be browser libraries like SAP Fiori or SAP UI5, but also other clients like native mobile apps or even test tools like Postman. Let's take a closer look at the first option, the SAP Cloud Application Programming Model. The key building block and backbone of CAP is CDS. Its declarative nature fits really well the need to capture service definitions, data models, and queries. Next up, there are the service SDKs. These are libraries for both Java and Node.js, which you use to expose and consume services. The SDKs also includes out-of-the-box integration to lower-level platform services, such as authentication and messaging. We provide first-class support for SAP services and tools like SAP HANA and SAP Business Application Studio, our IDE of choice, plus integration to other IDEs like VS Code and Eclipse. These are some of the tasks that the programming model wants to support developers with. They range from starting a project to defining and running services, connecting to databases, serving front ends, adding test and business logic, wiring things to cloud services, and deploying the application to SAP Cloud Platform. Let's see some of these steps in action. I will start right off the bat with a clean terminal, and I will use the CDS command line utility to create a project. I'll use the CDS init command and give it a name, let's say bookshop, just like that. Then go inside the folder and open Visual Studio Code using that command line utility here. Also installing the dependencies behind the scenes. Okay, so VS Code has opened. Let me zoom in a bit. That's the project structure of our little application. You see it's basically just a list of empty folders and some configuration files. The first thing I could try to do right out of the bat, that might be surprising to you, trying to start the application actually. I have opened a terminal here in VS Code, and I can again use the CDS command line utility and type in CDS watch. And what that will do, it will try to start the application and relaunch it whenever a file change occurred. This time, in this situation, it says, well, there is nothing to start off, and that's what we now will add. I will create a file called schema.cds. Any .cds file will do, and fill in some content. I've prepared a bit of content here, which is CDS definitions. You might have seen that before from either the ABAP or HANA side. It basically defines some entities. By the way, you can also use the outline here to make yourself familiar with the structure of the file. It defines some entities like books, authors, orders, and order items. Books basically has a number of attributes here, and then links to the author's entity. You see that through an association. The author then links back to books, to many books. Orders has an ID and order number and links to a number of order items through composition. And these order items are defined here. So it's a quite straightforward data model, but gives us enough interesting things to talk about. For instance, you would see that using statement here that imports entities like the managed entity. You see that appearing quite some time with that colon notation, and it means these entities inherit from the managed entity. And if you hover over it and hold control, you can actually see what's inside that managed entity. Actually, it's an aspect, so like a type definition, with a well-known administrative fields. You might also know that from the ABAP environment, like the typical created at, created by fields, etc. And these get automatically filled at runtime. In the same way, by the way, the keys are automatically filled if they are UUIDs. You see some annotations already here where you can nicely add some text or even localized keywords over there, which means at runtime we can serve data in different languages. It's a bit like the ABAP text tables. Okay, so that's our database data model, so to say. Next up is a service model. I call that something with service.cds, maybe even cat service, because we want to create a catalog service, like so. What that does, it basically uses the other file, our schema.cds file here, imports entities, and it defines a catalog service that is going to be served at the /browse path. And it just repeats on these entities, basically just projecting on the entities that we have just imported from the schema.cds file. You might also place them side by side so that you can basically see that's a one-to-one mapping to just keep things simple. Down there on our watcher, CDS Watch is still running, you've seen that it now has managed to launch the application without us having to restart anything. I can click here and sure enough, we see the application running. So that's already the full application. We can, for instance, click on $metadata. We see OData metadata in version 4 this time. But we can also click on authors or books, see that nothing served. Of course, there's no data, but it seems to be at least running, which is quite encouraging. The next thing we will probably do is to have some data that I will put inside. So let me do that real quick. And I copy in a data folder here. And what the data folder contains is just real simple 2 CSV files. And down there you see that our watcher has already detected that and says filling this entity with that CSV file. Why could it do that? Yeah, well, because the CSV file is exactly named like the entity. So it can automatically fill an SQLite in-memory database. See that? So that's what is backing our application. So if we go back to our application and now click the author's entity, for instance, we see now all of the sudden data. So that's really an application that is backed with the database, SQLite in this case. Cool. So the next thing we could maybe do is add some logic, right? What is an application without logic, business logic? we create a JavaScript file which is exactly named like the CDS file, right? See the same name. By that, we allow the framework to automatically detect our code. You, by the way, see that already down in our watcher, it has detected this file. Now let's create some handler code here, like so. And you see that basically this file just exports a JavaScript function, okay? And it adds two what we call event handlers. One is in the catalog service after reading of books for each of the entities, the book. Whenever the stock exceeds a certain value, please modify the title and give a hint to a discount. Let's check that. Let's go to the books, list them all, and scroll through them, and sure enough, you see that some of them got a little discount hint. It's exactly these who have enough stock. So this is how we can tell that our code was actually already executed. We don't need to recompile anything. We had just to place a file there. Likewise, you might see the same holds true for this handler here, which before creating of orders, for all the items, we basically update the books and say, okay, let's reduce the stock by the order amount, but of course only for the books who are ordered, where the ID matches, and only if there's enough stock. If there is not enough stock, so no rows would be affected in the database, we yield an error. So this is how we can basically add more validation code, more business logic to the application. The last thing I like to show you is is Fiori annotations. So in any CDS file, typically in a separate file, but for the sake of brevity here, I'll do that right here in that file, we can add annotations. You see that annotating the catalog services books entity, so exactly this guy here with a couple of annotations. And these are UI line items and UI header info. And this is exactly the original Fiori annotation. So there's no mapping in between, no like different style of annotations. It's exactly what you will find also in the documentation of SAP Fiori elements. Save that file. Our watcher has found it, has already merged it into the model, and let's check it. You see that little in Fiori link here, right? Let's click on that and see what happens. It will basically dynamically spawn up a little SAP Fiori elements application, and sure enough, we see exactly the line items that we have just declared. We are missing still the titles of the columns. I can quickly show you how you can easily do that by just using that add title annotation. So let's maybe for the ID of the book, give it a title and maybe book number, like so. Just save it, refresh the page, and here we go. So this is how we basically can very easily have fast development turnarounds for developing SAP Fiori applications with the SAP Cloud Application Programming Model. And now I will hand over to Corinne.
Thank you, Christian. Now I will give you an overview of the ABAP RESTful Programming Model, RAP for short. Here we have three key players. First, the ABAP development tools in Eclipse for all ABAP backend development activities on-premise as well as in the cloud. Then we have the ABAP language and the ABAP core data services as the main languages used for all standard implementation tasks. Last but not least, the powerful underlying application frameworks, which relieve developers of technical implementation tasks and allow them to focus on providing the business logic in a protocol-agnostic manner. The big picture of RAP shows its major building block and the typical development flow. It can be divided into three layers. Let's start from the bottom with the data modeling and behavior layer, which deals with the data and the associated business logic. On one side, we have queries for creating list report and analytical apps, for example. They are defined using ABAP CDS. On the other side, we have the transactional worlds of business objects. A business object, or BO for short, consists of three parts: the data model, defined using ABAP CDS, the transactional behavior, defined a new development object called the behavior definition, and the behavior implementation provided in ABAP classes. The syntax of the ABAP language and the ABAP CDS has been enhanced for this purpose. On top of that, we have the business services provisioning layers, where the scenario-specific scope definition and exposure of an OData service occur. The business object projection is used to specify the relevant subset of attributes and behavior of each business object involved. Here, business object can also be enriched with additional information if needed, for example, with SAP Fiori elements annotations. Then we have the service definition, also a new development object, where the list of all relevant business objects and other helpful CDS entities for a given service is specified. And then the service binding, also a new development object where the concrete binding of a given service definition to a given use case and OData protocol occurs. At the top, we have the service consumption layer where the published OData services are consumed. Two use cases are supported here: the development of SAP Fiori apps and the consumption of the exposed web API by third parties. The business object runtime mainly consists of two parts on the conceptual level: the interaction phase, where all read, modify, and log operations occur. All changes made here are temporarily kept in the internal transactional buffer. And the save sequence, where all check, save, and cleanup operations are processed to persist the changes on the database. The question here is, what are the developers responsible for? Well, RAP offers two major BO runtime implementation scenarios. In the first scenario, the developers want to reuse existing business logic. Here they are in charge of the BO runtime and have to implement adapters to integrate the existing logic into the RAP application infrastructure using the unmanaged implementation. In the second scenario, the developers want to start from scratch. Here, the RAP application infrastructure provides standard create, read, update, and delete operations out of the box. No single ABAP code line is required for that. The developers can then focus on adding the BO-specific business logic in dedicated code exits using the managed implementation. This scenario is currently only available on the SAP Cloud Platform ABAP environment. In general, the ABAP RESTful programming model is available on SAP Cloud Platform ABAP environment, as well as on SAP S/4HANA, starting with release 1909. Let's now take a look at the major development artifacts of the ABAP RESTful programming model in the system. This is our demo application. It is a simple travel processing app. We have here an SAP Fiori element list report showing the different travel data stored in the backend. At the top, we have search and filter bar. We have a toolbar here for the different end-user interaction and the list. We can navigate to the object page and edit the data. Save them. So we can see some validations are implemented. So let's provide a correct data value. Here we can make use of the defined value hub and just select the data and save it. Let's go back to the list report. And here we can see we have different operations. We can create a new one, we can delete one, or we have a one-click action implemented here where we can change the status to book. Let us go to the system and have a look at the different development objects involved here. First of all, we are here in the ABAP development tools in Eclipse, And I've already created a connection to my backend systems here, SAP Cloud Platform ABAP environment. And here is my demo package. So if you remember the big pictures, let's start with the data modeling and behavior layer. So here we use core data services to define our data model in a text-based editor. Here we can see this is our root business object, and the data are selected from a table. We have association provided for additional information, and here our projection list. With F8, we can just execute and have a data preview in Eclipse. The next step here is to define the behavior, and this is done in the behavior definitions. Here we can see this is a manage implementation type. I can see here the class where all the BO-specific implementations will be provided, and here some additional information regarding the persistency and the log handling. I can see that all the create, update, and delete operations are enabled. I have some feature control information, some validation, so very simple, and a determination to set the initial status of a travel, and here an action. The implementation of the BO-specific implementation is provided in a class. And as we can see here, the ABAP language syntax has been enhanced. And this class provide the implementation, the behavior implementation of this entity, which is stored as a local class. Here in the outline, we can see the different methods that are implemented in this class. So this is ABAP and with the enhanced syntax. So once this is done, now, it is maybe important here at this stage to emphasize that for the create, update, and delete operation, no single code line is provided for the standard operations. So now let's go to the projection layer, so to the business services provisioning. And here we have a projection with all the relevant attributes that are used in this scenario. And I can see here we have also a lot of metadata provided in form of annotations, UIs annotations, which are used later on for rendering the SAP Fiori element application. But I can also see some search-related information. Here are the value help defined. I have enhanced my view. So here I can enrich the business object. And for example, for the field status, I have defined an action. So once this is done in the projection here, we can go now also on the behavior layer and do a projection. So which operations, actions are allowed in this scenario. And here I have allowed create, update, and delete, and also the action. So now we can go on top of that and define our service definition. And this is done in the new artifact called service definition 2. And here I define all the business objects that are involved, that are relevant for my business service, for my OData service. And I can also add additional CDS entities, like for the value helps and so on. When we are through with that, now we go to the service binding. And here, using a wizard, we can simply bind our service definition to the protocol and the use case. In that case, it is bound to the OData v2 and to the UI scenario, because we can also choose to do it as a web API. And very soon we will also support OData v4, meaning that the developers can then expose the same service also as OData v4 service. And here we can use the service URL to access the OData service, or we can just make use of the embedded function Fiori elements to preview the app. And then you will see again the app I showed you at the beginning. That's it for the demo. The key takeaways of this unit are: SAP offers two powerful REST-based programming models on SAP Cloud Platform for building enterprise extensions for cloud-based and on-premise SAP solutions. Both programming models are based on CDS data and service model, exposed as OData APIs, backed by similar out-of-the-box request handling, and best support SAP HANA and SAP Fiori elements. The SAP Cloud Application Programming Model is available on SAP Cloud Platform for Java and Node.js JavaScript-based development on Cloud Foundry. The ABAP RESTful Programming Model is available on SAP Cloud Platform ABAP environment and SAP S/4HANA. It allows the reuse of existing ABAP skills and software assets. Another important information, customers and partners on SAP Business Suite 7 can develop enterprise OData services using the SAP Gateway Service Builder and the ABAP programming model for SAP Fiori.
Thanks, Corinne. And you can already get started now with the two programming models. Below you will find links to existing OpenSAP courses, getting started guides, and on the free trial environment. Thank you for watching and enjoy the next unit about SAP Screen Personas.
And goodbye.